In this final segment, we'll discuss associative containers in STL. So just to recall, maps or dictionaries associate keys with values. So they store key-value pairs. And in this specific example, we have the key-value pairs as the student ID with the corresponding GPA. And the keys are the student IDs. And the keys must be unique, but there are no constraints on the corresponding values. And there's also no inherent sense of ordering in a map among the key value pairs. So for example, we can't get the fourth or the fifth or the first key value pair in a map. It does not have that sense of ordering. However, it is considered associative because we are associating a key with a corresponding value. So we'll see we can access key value pairs in a map by using the key. The operations that we want on a map are insert, remove, find or lookup, as well as checking if it's empty and the number of elements in the map. In order to implement a map, C++ provides a pair struct. The pair struct contains two values, first and second, and you'll notice that the key value pairs can be represented and stored in such a pair struct. But I want to point out, and we'll get to this more in a subsequent video, that it is a struct that is implemented using a template. And when we use a template, we pass the type as parameters. So here, a pair has two types, one for the key, T1, and one for the value, T2. So you'll notice inside the struct that first is of type T1 and second is of type T2. And map, C++ map, stores its key as the first value and the value as the second value in the pair. When we want to instantiate a pair, we can just instantiate an object passing the values that we'd like for the key and the value, or we can use the makePair function. So let's take a look at what this looks like in main. I would like to create a pair where the first value is string and the second value is of type integer. I'll name my pair P1, and you'll notice that I pass to the constructor for the pair struct a string, and the second value is an integer. If I want to print out the values of my struct, I use the dot operator, and to get the string, I have to use first, so that's P1 dot first will get the string, and P1 dot second will get the integer that's the second value. This can also be done, we can also create pairs by using the makePair function. And to do so, we can use the function makePair, and we pass it a char and then a double. So this is the same as creating a pair where the first is of type char and the second is of type double, and then we just pass the character and the double to the constructor for the pair. It's important to note that if you would like to use pairs directly in this way, you must include the utility library. If you use map, it is not necessary to include utility because you'll include the map library. Now, let's look at STL map. In order to use STL map, it is necessary to include the map library. As we had mentioned, the maps will store the key value pairs. And you can store elements in a map by making such key value pairs directly, or we'll give another way to do this using the subscript operator. As we had mentioned, the keys in a map must be unique, and the values must have a default constructor. An important element of using and implementing keys is that any type that you would like for your key objects must have the less than operator defined for it. So let's take a concrete example of instantiating and inserting objects into a map. First, you'll notice we declare our map. When we declare our map, we have the angle bracket, but you'll notice this has two parameters. We have to pass the parameter type for the key and also for the value. So we are creating a map with string keys and double values called bodega inventory. Now, if we'd want to insert key value pairs into our map, we can use the square subscript operator. You'll notice that this is overloaded for the map class. And what I mean by that is you'll notice that for arrays or vectors, we pass an integer into the subscript operator. But here, we actually pass a key, because a key is what is used to associate with the value. So rather than passing an integer, you have to pass a key type to the square bracket operator for a map. So here we want to insert into our map the key plantains with the associated value, which is 99 cents. So that is one way you can insert values into a map, by just using the square bracket subscript operator. Another way is you can just use the insert function on your map, but here when you insert, you have to insert a key value pair. And as we had just seen, there's two ways to do that. You can instantiate a pair, so you have the pair with string double, because we want our key to be a string and our value to be a double, and we pass to the constructor for the pair our string mangoes with the corresponding value for the price too. Similarly, we can just use the make pair function. So for make pair function, you pass the key type. In this case, we're going to pass bread as the key, and the corresponding double for its value, $3.99. So we've just inserted 3 key value pairs into our bodega inventory map. Those are plantains for 99 cents, mangoes for $2, and bread for $3.99. Now, if we'd like to figure out what the corresponding value is for a key in our map, we can also use the square bracket operator. But you'll notice now we are passing in the key, a string for the key. So we take the name of our map, which is bodega inventory, and we pass it the key mangoes. And the return value will be a double, which is the corresponding value for the key mangoes. In this case, it would be the mango price. And if we want to remove from a map, we can just use the erase function. So given the name of the map, in this case bodega inventory, we call the erase function with the corresponding key of the key value pair that we want to remove from the map. In this example, we've created a map called bodega inventory, which is a map with key value pairs where the keys are C++ strings representing the foods, and the corresponding double values are for the prices. Let's discuss how we can iterate through our entire map. So here, once again, we've declared our inventory, and now we need to declare an iterator in order to traverse our map. The first thing that we have to remember is that we have to declare our iterator to the map that we have just created. It has to have the same type. So we have keys that are strings and values that are doubles. So we have to have a map which has the first type set to string and the second set to double, the scoping operator, the word iterator, and we declare the name of our iterator to be just it. Once again, we have to set our iterator to the first key value pair in our map. To do so, we have to then use our map object, that's bodega, and we have to call the begin function on our map object. This will return an iterator to the first key value pair in our map. Then we want to make sure we have not exhausted our map. And in order to check for the iterator to the end of our map, we just have to call the end function on our map object. And then if we want to advance to the next key value pair, we increment our iterator. Once we have our iterator, if we want to actually access the key value pairs, we have to remember that this iterator behaves as though it is a pointer to a key value pair struct. In order to print out the key, we have to use the arrow operator and then access the first field of the struct, because the first is going to be the key. And in this specific example, our keys are strings, so the first will print out the string for the food. And to access the corresponding value, we have to use the iterator with the arrow operator and second, because that will give us the double, that is the corresponding value. So we can think of the iterator to the current key value pair in a map as though it is a pointer to the C++ pair struct containing that key value pair, and the first of that struct will be the key and the second will be the value. You'll notice that when we actually run this code and we print out the inventory, we will have it sorted in alphabetical order by the keys. So we printed out bread for $3.99, mangoes for $2, and plantains for 99 cents. Now, it may be possible that we do not want to print out the entire inventory. We may just want to search the inventory for a specific value. In order to do this, we can use the find function of our map. Once again, our find function needs an iterator because it returns an iterator. So as before, we would declare our iterator to be an iterator to the type of map that we've declared. So here, once again, we have a map, which is string key double value pairs, and we have the scoping operator and the word iterator, and then we declare our iterator IT. Now, when you use the find function on a map, you pass as an argument a key. So the argument that you pass to find has to be the same type as the key. So in this specific example, it has to be a string, and we pass the string apples to the find function on our map object. Find will return an iterator. If the key that we've passed to find is in the map, it will return an iterator to the corresponding key value pair. And just as before, if you want to get the key, you would use the iterator with the arrow operator and get first. If you want to get the value, you use the arrow operator and second. So that's how we can use the iterator as though it is a pointer into the key value pair. If whatever key you had searched for using find is not in the map, find will return end. So end is the indication that the key is not in the map. Recall, to get end, you have to take your map object and call the end function on your map object. So if find returns the end of your map, that means that key was not found in your map. So in this specific example, we search on our bodega map, so we call bodega find, we pass the key apples, and we store the iterator returned in it. There are no apples in the inventory, so this iterator will be equal to bodega end. That is the iterator to the end of the map. So this code would print out no apples this week. Maps are very efficient in checking for specific key value pairs, and this can be done in O of log n, where n is the number of key value pairs in the map. We'll discuss some of how this works a little bit later, but I want to mention that this is much better than performing linear search on a list, and this is some of what makes maps so useful. Now let's look at the STL set class. In order to use set, you have to include set library. As with maps, the keys are unique and sets are only keys. Now they have insert, erase, and just like maps, sets are very efficient for testing membership. So we can do it in O of log n, where n is the number of elements in the set. Just like with a map, a set must have key types that have the less than operator defined on them, and it is possible to iterate through all of the elements in a set and also to test membership using find. So let's just trace through this example in main, which is very similar to what we have done with maps, but now using sets. So first, we declare our set of strings, and we pass in the type of keys that we want as a parameter to set, and here we're calling our set fruits. And then we can insert apples and watermelons, and you'll notice that when we use insert, we are just inserting a value of the key type. So here we have to use strings because all of our keys in our set are strings, and we can also insert grapes. So sets are just the key values. Now, if we want to iterate through our set, we have to declare our iterator. You'll notice that our iterator must be of the type of the set that we just declared. So we have a set of strings, the scoping operator, the word iterator, and then we call our iterator it. If we want our iterator to go through our fruit set, we have to call the begin function on our fruit set, and we check that our iterator has not reached the end of the fruit set that we had just declared. Now we increment our iterator as before with just using the plus operator. And now if we want to print out the current element at which the iterator is pointing in our set, we can just dereference it. So when we do star IT, we will print out the current string key in our set. Similarly, we can call find, and you'll notice when we call find on our set, we have to pass a value which is the type of the keys. In this case, our keys are strings, so we check if the fruit set contains cabbage, and we compare the result to the end of the set, which is the iterator to not included, to the first element not included in the set. So that would indicate that it's not in the set. In this specific case, find would return fruits and the iterator to the end of the set, and in which case we would print out cabbage is not a fruit. Similarly, if we want to erase from a set, we need only pass in a key value that has to be of the type of the rest of the key values. So here we have a set of strings. We pass a string to erase, in this case watermelons, and fruits.erase with the argument watermelons would remove the key watermelons from our set of fruits. So when we are dealing with set, you'll notice that the functions are very similar for map. The only difference is that rather than dealing with key value pairs for a set, you only need to deal with the key values. Now, this is a little bit of a precursor, but I wanted to mention how maps and sets are so efficient. Maps are and sets are so efficient because they store their keys in balanced binary search trees. And in a few weeks, we'll actually show you how you can implement your own balanced binary search tree. And it's the balanced binary search tree which permits find to be implemented in logarithmic runtime. But this is also why we need the less than operator to be defined for the key data type. The reason for this is that inside the balanced binary search tree, those keys will be sorted based on the key value. So we have to be able to compare them. So as we can see here, if we had more extensive inventory of our foods with their corresponding values, we would search our balanced binary search tree in order to find the key. So if we searched on figs, we would return back an iterator to the key value pair with figs and the value 499. But if we searched on pineapples, we would not find it, so find would return an iterator to the end. So this is a little precursor for what you will be learning how to implement. So you'll be able to write your own map class in just a few weeks.